Welcome to solverfy.
Right, so when we look at this first reaction, we're looking for major and minor products. Right, now the general rule is that the hydrogen will attach wherever there are more hydrogens already. So we have a double bond to start, okay? And when we add that water, what we will see is that the hydrogen will go to the CH2 over that double bond because it already has two hydrogens, whereas the CH only has one, so that gets the hydroxide. Right? The minor product would be the same format, same formula, but instead it would have the hydrogen on the inside and the OH on the outside. All right, the major products for the rest of these, as we look at them, okay, be the same kind of idea. We're going to follow that same general rule. So for the next one, we have CH3, CH2, CH double bond, CH2, right? We know the bromine will add to the one with less carbon, with less hydrogen. The hydrogen will add to the one with more. Right? On the next one, we have a triple bond, which gives us the opportunity to actually take that down to an alkane. So while we start with a triple bond, okay, so very similar structure here, okay, let's back that up. So that's a CH to start. Since we are still adding HBr, we still follow that same rule. The hydrogens will add here, okay, and actually this hydrogen shouldn't be here, right, to give us those four bonds to each carbon in our structure. Right? Works the same way for our ring compounds. So we have that pentene ring with a double bond to start with that methyl group. So again, wherever there was more hydrogens, which would be the group without the methyl, that's where the hydrogen will go, so the OH goes to the other side of that double bond. Right? And finally, we have our double bond between the two carbons here. Right? So we start with a methyl, right, and a one hydrogen where the double bond is, and we have an ethyl, right, and another methyl. Right, so across what was the double bond, right, so what would have been there, we are going to add that HCl, okay, so that adds across the double bond. There's more hydrogen on that terminal carbon first, which means the chlorine will go on the second carbon, okay, the opposite carbon in that double bond.